Since you're taking a DCP next class, there are 5 things we need to talk about again before you take that district checkpoint. The first topic we're going to go over is solving for x. Now, a solving for x question may ask, what is the solution to the following equations? We know that the keyword solution here and the fact that we have a single variable equation means that we're looking for the value of x that makes the equation true. We can use the box method to do this. The box method and the inverse operations method both start by using distribution. So I'm going to distribute on both sides of the equal sign here, the -1 and the -3. When I do that, I'll have -7x plus 7 plus 2x on the left-hand side and -9x plus 24 on the right-hand side. All I've done is distribution, which is multiplication. After I've done my distribution step, you can continue using inverse operations or you can set up your boxes. When we're setting up our boxes for this single variable equation, I ask myself, how many terms have an x in them? There are 3 x terms, so I'm going to make 3 top boxes on the left-hand side, and there are 2 constant terms, so I'm going to put 2 boxes on the right-hand side. Let's drag and drop. So I'm going to put all of the x terms on the x side, knowing that when this -9x crosses the line, it's going to have to change signs from negative to positive. Then I bring all the constants over, knowing that when that 7 crosses the center line, it's going to have to change signs. Once I have all my terms in the appropriate box, I add them together. -7 plus 2 plus 9 is 4x's. -7 plus 24 is 17. Last but not least, I divide by that coefficient of the x onto both sides, and I would get a decimal answer, which you guys know I'm going to like as the fraction, 17/4. Now, if we want to check our work, because we're taking a test here, so we want to make sure we're getting this right. We're going to use Desmos to do that. Here is a video example that I'll talk you through that shows you how to check your work on Desmos. So let's say that we have this equation. We're going to put the left-hand side and the right-hand side of the equation that was printed on my paper into Desmos. We look for where the lines cross and notice the x term is 4.25. But since I wrote my answer as a fraction, I'll just change that number to a fraction. 17/4 is the x value that we got, so it's going to be the x value for this equation, just like we got here on our paper. Remember, by putting the left-hand side and then the right-hand side into Desmos. The second topic we need to go over is solving for y. There may be a question on your DCP that asks you to solve an equation for y, or it might say which of the following is equivalent, and have a bunch of equations that are solved for y. That means you're just trying to rewrite the standard form equation into slope-intercept form. There are 3 very easy steps. First step is to move the x term across the line. Bloop, cross the line, change the sign. We then very easily rewrite the entire equation. We have -5y that drops down, a now -2x, and a positive 75. We're going to divide each and every term by the coefficient of the y. When I divide everything by -5, I'm going to end up with 2/5. You're going to get 0.4 in a calculator, but you'll make that a fraction of 2/5, and you'd get a -15. So y equals 2/5x minus 15 is the equivalent equation to that standard form function. We have solved for y, or we have written it in slope-intercept form. The next topics we're going to have to go over are all about functions. When we're talking about functions, we spent a lot of time talking about domain and range. We have pretty much nailed down the vocabulary, but let's review really quickly. When I'm asking you about the domain, I'm talking about the x values or the independent values, the inputs. When I'm talking about range, I'm talking about the y values or the dependent variables, the outputs. When I have just a discrete situation, I'm going to list all of my domain and range in the funky little brackets. But when I have a continuous set of data, I'm going to have to describe it with the left to the right and the bottom to the top, like Dolor the robot helps me remember. Line, triangle, box, triangle, line is the pattern that we're going to use to fill out our domain and range for continuous functions. Remember, these are the ones that are connected. If your graph is disconnected, you're using this list. we have the left number and the right number for the domain, which is your x's. We have the bottom number and the top number helping you describe the range, which is your y's. We also have to remember that when we see on a graph that there are endpoints, that the endpoints that are closed use the symbol less than or equal to in the triangle shape here. If your symbol is open, you're just going to use less than. If you write more, you have to write more. If you write less, you have to write less. Bonus that if you notice that the graph is going off forever and ever, it's either going to head towards a negative infinity or a positive infinity. We know the vocabulary of domain and range. Let's go over some of the vocabulary involved with slope. Slope guy helps me remember the 4 types of slopes. We have our positive slopes going uphill. We have our negative slopes going downhill. We have our undefined slopes that are going up and down. And we have our zero slopes that are flat. Positive, negative, hoi, and vux. The Rockham's formula, this is written like this because rate of change and slope are the same, and they're represented by the variable m. The Rockham's formula is y2 minus y1 over x2 minus x1. Now we're getting these first and second y's from our table. We can label these. Here's the first x in the table, here's the second x in the table. This is the first y in the table, that's the second y in the table. So if I'm trying to find the slope of the function represented in this table, all I need to do is fill out my formula. The first y is 0. Sorry, the second y is 0. The first y is negative 2. The second x is negative 5. And the first x is negative 9. Taking them exactly out of the table and putting them into my formula. At this point, you can throw that into Desmos, but if you're doing this in your brain, 0 minus negative 2 is like 0 plus 2. That's 2. Negative 5 minus negative 9 is like negative 5 plus 9, which is 4, which means that my slope is 1/2. You can also find slope by counting the rise and the right, rise over run, for a graph. Now let's talk about graphs. We spent some time writing and graphing equations in slope-intercept form. The main vocabulary we need to remember with slope-intercept form is that in y equals mx plus b, you must have that y equals part. If your equation does not say y equals, you cannot graph it the way we've been practicing. You need it to be written in y equals mx plus b form because the m tells you your slope, which is also the rate of change. This is your rise over your run. So it tells you how much to move along the graph, the m for move. There are 2 words that help us in word problems. Remember, we're talking about the slope. One of those words might be rate. It might be per, it might be each, or every. Those are the vocabulary words that help me know, and from a word problem, I'm talking about slope. The only other thing you need to graph and or write an equation in slope-intercept form is the y-intercept. That's your b value. Okay, another word for this is the initial value, because that's where you begin or start. There's your B. Remember that this is on the y-axis, which is the up and down axis. That's where you're finding or placing the y-intercept. Last example problem for today, we're going to graph this function. The first thing I want to know is, can I, right now, the way this is written, graph 5x plus 3y equal 30 with the skills you have? Now, well, we've been practicing graphing in slope-intercept form, which means we're going to need to solve this for y. Didn't we already practice this skill? Look, we get another practice problem. We're going to move the x term and then rewrite the problem down. 3y equals negative 5x plus 30. Very easily, we just divide by the coefficient of the y, which is 3, and we'd get negative 5/3 x plus 10. Negative 5/3 x plus 10 is great because I automatically know the slope, which is negative 5/3, and I know that y-intercept, which is going to be at the coordinate 0, 10, meaning it has an initial value of 10. Great, let's do it. We're going to start at 10 on the y-axis, which is the up and down axis. That's my initial value or starting value. From that point, I'm going to count down 5 jumps. 1, 2, 3, 4, 5. I'm going to count over 3 jumps. 1, 2, 3. And there's another coordinate. Boom, right there. Repeat. 1, 2, 3, 4, 5. 1, 2, 3. For good measure, I'm going to do that one more time. I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3. Once I have a good number of coordinates on my screen where I know I've graphed this correctly, I'm going to lay down a ruler or some sort of straight edge and hopefully draw a straight line. You know, I'm using a ruler and I'm still drawing not straight lines. Feel free to laugh at me. Now that I have this graphed, I know exactly where my y-intercept or initial value is because I started there. But once I have it graphed, I can find the x-intercept and the 0. Because remember, your x-intercept and 0 are the same place on a graph. The x-intercept here is where the graph crosses the x-axis, and that would be the coordinate 6, 0, which means the 0 is 6. So we know about our slopes. We know about our x-intercepts, our zeros, our y-intercepts, our initial values. Those are the main vocabulary words you need to make sure you have cleared up in your head before this test. Slope is the rise over run. Y-intercept and initial value is where the graph begins on the y-axis. The x-intercept and the 0 is where the graph crosses the x-axis, which is the flat axis. If you have a good understanding of these 5 topics, amongst all the other things we've studied so far this year, you will do absolutely fine on your DCP. See you in class.